First of all, welcome everyone. Good morning. This is incredible. So many people. I have the great honor to start off this conference. It's also a bit of a challenge because I want to make sure that everyone is on the same page, which makes it a bit hard. In this talk, I'll start with the very basics, but I'll end up with the more advanced stuff. So there'll be something new for everyone here. I just want to say thank you for everyone who's here. This has been an incredible journey in the last 1 or 2 years, and well, look at where we are now. So let's get started. Ecash systems are private cypherpunk money systems, and this is in opposite to public money systems, and with which I mean Bitcoin. David Chaum, the guy we saw in the slide before, invented ecash in 1982, where he had this genius idea to issue bank-issued electronic bearer instrument to users. And these users would then be able to make privacy-preserving online payments with these digital tokens back in the 80s. This was a big idea because this also laid the foundations of how the web was supposed to monetize. This was before the advertisement model was a thing. Like cash, ecash is supposed to be private, uncensorable, no accounts and no user databases, but it's electronic. So it's instant and users interact or exchange value peer-to-peer, and the mint makes sure that you can't double spend. And you can do these payments online as well as offline. Everyone loved this. We had Microsoft, Deutsche Bank, Credit Suisse, Citibank. There are more names I could drop that were in hashing out deals with the companies by David Chaum. The problem of ecash has always been that it always relied on the banking system itself. So these ecash systems that people were dreaming up in the 80s and 90s needed to be built by the banks themselves, and it needed to run on the banking system. As we all know from history, ecash never fulfilled its promise that it laid out in the 80s. All these deals were cancelled, and this is mostly to do, in my opinion, with the centralized dependency on the banking system. And a decade later, only a decade later, there's a huge gap between eCash's failure and the proliferance of PayPal and credit cards and the entire online internet payment systems that we have built since then. So here's the general idea of how it was supposed to work back in the 80s. So we start with Alice, who is a customer of a bank. She has a bank account, a normal bank account. The bank is running an ecash mint. So this is the idea by DigiCash in the beginning. Alice would take fiat from her bank account and send it to the mint. The mint is run by the same entity. The mint in return issues ecash, now that you see as this pink icon, and gives that to Alice. Alice now stores this in her super old classic Windows 3.11 or it's actually Macintosh wallet. Alice then goes shopping on the internet that started, just barely started existing, finds products that she likes by Carol, and then sends over that digital cash via email. For example, you see here a payment request to a mail address. And Carol would then collect ecash during the month, for example, and then at the end of the month go back to the ecash mint, and then the ecash mint would issue the fiat back into her bank account. So this was the intended flow of ecash. So where is all this? It was supposed to, as I said, power the entire web. And I just want to make this very explicit. David Chaum was an incredible forward-thinking person. In 1982, this is so much earlier than the normal people started using the web. He already knew that privacy is going to be one of the major problems in the internet age. He knew that we're going to pay for almost everything digitally, and he knew that we're going to organize our lives digitally. And he already predicted and said, and this is a well-quoted sentence by him, in order to protect democracy, we need financial privacy. So the history of cryptocurrencies begins here, and we all know that the most significant event happening after the invention of ecash is 2008, Satoshi's invention of Bitcoin, which is now a decentralized solution to the electronic cash problem. This is something completely new, a very different approach, and the research leading up to this point has always, like most of the research, has assumed that we're going to go with this centralized model. And this decentralized electronic cash idea was very far away until Satoshi proposed this solution. Now, Bitcoin has ridden us from the need of a trusted third party in order to use money. However, the fundamental inability of blockchains to scale still means that most activity on Bitcoin happening today, expressed as number of transactions, is custodial. So what if we took the good ideas from the 80s and put it onto the new financial open monetary network that everyone can build upon? And this is what happens. This is an incredibly bullish slide. This is my favorite slide of this entire presentation. And I've built only two things of this list, and there's been incredible achievements. So many different wallet implementations. The Mint implementations that you see here are in different programming languages developed by independent programmers, all possible through a system that we have developed, protocol specifications, which are something like a shared language between us. And if you read those documents, you'll be able to build one of the apps that is compatible with the rest of the ecosystem. There's been particular uptick in Nostr, where social clients have started interacting with ecash, making it super easy to send around ecash to your peers and friends online. And this is very typical for a new system like Nostr, that isn't invested into an old solution. I think it's very natural to see that we are seeing adoption on something like Nostr, and it will take much longer for legacy systems to pick up on newer innovations. The reason why we could do this is not because we're geniuses. People in the 80s were also very smart. The reason is Bitcoin. This is literally it. So when you think of a mint has a set of different users. And these users within the mint can interact with each other using ecash. If there's a second mint, those users will interact with a different ecash denomination between each other. So now, obviously, there can be users who have ecash from two different mints. They could serve as a sort of intermediary between those closed systems. However, most settlements between the mints will happen over Lightning. And this is possible because the mints, both of them, trust the Bitcoin network. And when you do that, you can create a bridge between these subsystems that are very easy to bootstrap. So we can create dozens and thousands of these mints, and we can scale this infinitely horizontally and make them all talk to each other because of the shared language of Bitcoin. And 1,000 mints blossom. Now, the previous slide was just a graphic. This is an actual network of individual Cashu mints run by independent people. And this is from a new audit tool that I've been working on that monitors these mints for their activity, whether they're able to send payments between each other or not. So we're seeing these maps and networks of mints emerge. So I like to say this, and I like to say it again, Bitcoin fixes ecash. Even ecash, like Bitcoin fixes everything, but also ecash. All right, brain dump. Now I hope we're almost on the same page, and after this page, like this will be the conclusion of my introduction, but I will just do a brain dump and give you a lot of information in a short period of time. First of all, we're dealing with, as I said, digital bearer asset. You hold the money in case of ecash. It is not stored on a blockchain. It's not on a ledger. The piece of data that you have in the phone is the money itself. Everyone can run a mint. So these mints are very lightweight. You can run them for an individual small website with a couple hundred users, or you can run them for a huge financial institution that needs to serve thousands of users per day. So this is extremely scalable and extremely lightweight at the same time. ecash can be its own shitcoin, or it can represent a real asset, and we're obviously only interested in a second. The state of ownership of ecash is not defined by the state of the ledger. This is in contrast to Bitcoin, where the state of ownership is defined by what the Bitcoin blockchain says. For an ecash system, there is no central ledger that says who has what. The state of ownership is only defined by what do you have in your pocket. Transactions of ecash are peer-to-peer. I send it to you directly. The role of the mint is to prevent double spending. And although this is a custodial system, it is eerily irreversible. And I'd almost like to say it's more irreversible than Bitcoin. And I know this sounds unintuitive, but once a transaction happened, once I sent you ecash and you swapped it out with a mint once, there is no way for the mint to reverse this transaction. They can only delete entries from a database, but that doesn't make this transaction reversible. We have spending conditions for user-defined scripting. This is a fancy way of saying we have smart contracts. And ecash has insane privacy properties. That means it's best of the class privacy. It can give you almost like theoretically optimal privacy. And the important part of this is the privacy guarantees censorship resistance. This is also an unintuitive fact for Bitcoiners, where the fact that you can't turn off Bitcoin is what gives it censorship resistance. In the case of ecash, the fact that the mint cannot differentiate between you and another user is what gives it censorship resistance. The mint can either block everyone or none, no one. All right, let's come to the next part. And here I want to talk about the emergence and this co-development of Cashu and Nostr. Cashu and Nostr were by accident or by pure chance invented at around the same time, and people started working on both at the same time. And you know, once you start building an ecash system, one of the first things that you realize after a couple of iterations is that you need a layer to send data around. This is one of the first things that you realize. I want to send you money. How? Now, as you can imagine, and also evidenced by all the different projects that I'm going to talk about, Nostr offers itself as the ideal medium, basically, for Cashu. As a project itself, like from the perspective of a project, it is such a big task to also build the communication medium to your payment system that you're actually developing. So it's great that we can make use of an existing system like that. So here are a couple of interactions why these two mix up so well together. So as I said, ecash needs a peer-to-peer layer. I need a way to get data to you. Ecash can benefit from an identity layer. I would like to send you money and no one else. It can benefit from a public square layer. That means we can announce mints to each other. We can rate mints, and the mint cannot block these ratings, so we can have social webs of trust. And Nostr also offers more resilient infrastructure for ecash mints. We can communicate, instead of HTTP, we can also use a Nostr network for it, or other things I'm going to mention. Well, on the Nostr side, Nostr can benefit, I wouldn't say maybe need is a bit too strong, but definitely can benefit from a payment layer. We've seen that also with Lightning. Zaps are one of the most popular things on Nostr. Since relays are open systems, they essentially require some form of DOS protection. Right now, relays basically rely on IP address and pub keys to use rate limiting. Once the privacy on Nostr improves, the pub keys won't cut it anymore. So something to limit the rate of use of a Nostr relay is also needed. And lastly, relay monetization is a big thing. We're all talking about whether Nostr will be sustainable or not. One of the ways to make systems sustainable, and this is something that we should really remember from, as I said, in the 90s, is to pay for them. Okay, some Nostr innovations that people have come up with. First, on the mint side, how do mints profit from Nostr today? One of the coolest things is mint discoverability. I think it's NIP 80 by bitcoinmints.com. This is an amazing software that collects different mints that announce themselves on Nostr and ratings by their users. So we have also ratings that can be posted on Nostr. You can see this mint and 5 of my friends recommended to use this mint, so I'm going to use this mint, for example. We're seeing distributed ecash storage. This is NIP60. What you can see here is on the left, you see a Nostr client. This is highlighter. And on the right, you see a Cashu wallet. This is Nutsack. Both are creations of Pablo. And you can see that both wallets have the same ecash balance. And although this looks primitive, it is actually a big challenge for ecash. I'm going to talk about that later. But this allows you to store the ecash not only on your device, but also in the Nostr relay itself. So you enter your NSEC in the app, and then your money pops up. And this is basically the goal that they were trying to achieve. How can I build a wallet that I can take with me wherever I go? And as I said, also independence from DNS is something really cool. We would like to be able to talk to mints without having to use DNS that can be just turned off by centralized entities. Mints could also publish in the future, this is something that's been talked about recently, publish the database on Nostr itself as a form to improve their proof of liability. So Nostr can be used also as an announcement system for mint information. On the wallet side, we're seeing, like, in the beginning, this was one of the first things that people did. We can send ecash via DM. Like, it's the first idea that you get. NIP4, NIP17, there are bad ways of doing DMs and good ways of doing DMs on Nostr. There is now a way to zap ecash on nodes. It's NIP61, so it's related to NIP60, also by Pablo, which locks ecash to a Nostr node. So the zapping experience that we're trying to replicate that we know from Lightning, we can also do for ecash. In the case of ecash, you press a button, it's done, always, and always instant, and always works. We use Nostr today to control wallets, Lightning functions today, hopefully soon also ecash functions directly through Nostr Wallet Connect. And currently we're working on Cashu payment requests. This is something similar to a Lightning invoice where the receiver can tell the sender how to reach me. And one of the ways to reach me is via Nostr. All right. I want to come to some challenges that I've been thinking about in the last couple of months. And I think these are bigger challenges that we still need to figure out solutions for. And I want to put them up here so maybe we can also discuss them in the next couple of days. So I want to summarize them with first point, backup and portability. Second one is auditability. So I call it trust but verify. And enforceability, which is don't trust, verify. So let's start with portability and backups. So long story short, we don't have a good solution yet. What do I mean by portability? It is essentially the problem I described before. You want to go to a website, it's a random website, and this website integrated ecash somehow. And you want to just press a button and your balance is there. Or you just want to press a button and it makes the payment. We still don't have a great way of synchronizing ecash between different instances on the web, but we will get there. Browser extensions are one way of doing this, the easy solution, so to speak, but browsers vendor lock you and they're just simply not popular. Now, when you want to store your ecash in a way that a website can access it, you are faced with the question, are you going to do a centralized storage system like an API or a distributed storage system, maybe like Nostr? When you store your ecash on a remote server, it's going to be encrypted anyway, right? So we don't want to introduce yet another level of trust where you need to trust the storage system to also not rug you, basically. But you can encrypt the money and put it there, and no one can take it anymore. But when you do that, and you should do that, question is like, how do you do coin selection? Like, imagine you put your wallet up, in the cloud, and now you want to pay 100 Satoshis. How do you get the 100 Satoshis out of that blob of data that you stored somewhere? So question is remote versus local coin selection, which is a trade-off between bandwidth and privacy. So either you download the entire wallet and then coin select and then upload again, or you ask the server to do coin selection for you, which might have privacy implications. So maybe there's some ZK magic. This is like a ZK maybe. Maybe there's a ZK way of doing coin selection in the cloud without the server really knowing what you're doing. Now, on the second 2 points, auditability and enforceability, we can make a simplified one-dimensional line here that I want to draw here. With the first point being what I call OG Chaumian ecash. This is trust me, bro. Then in the middle, we have the next step would be auditability, trust but verify. And the end of that scale is enforceability. Don't trust, verify. So we are here. And even in the case of Fedi Mint, you have less trust than in Cashu, where you'd rely on a single operator. But also if they collude, you're still at the trust me bro level. And I think we can get to the auditability. Like I have a clear idea of how to get there, which means like even if we can't stop the mint from rugging or cheating, we can prove that it's rugging or cheating. And that's already a big, big step. And on the very right scale, enforceability, that's kind of like the holy grail. This could be that we can achieve this because of Bitcoin at the end of the day. It would be such a nice historical turn that ecash has always been like this bigger problem of ecash was the centralized nature and the fact that you cannot prevent rugs. And then Bitcoin came as an alternative to that. And it would be very interesting or nice to be able to secure ecash back with the technologies, the properties of Bitcoin. So on auditability, this is something that I proposed a year ago or so. Lots of people have read it. It's a proof of liability scheme that gives users some way of making sure that the mint is not doing fractional reserve or printing unbacked ecash. However, this has some caveats that are serious caveats, I think, and one of them is it requires everyone to do the check in order for these proof of liabilities to work. It is not in real time, so you only can detect like inflation in the past. And if some users die or never open their wallets again, then it becomes just less exact. The precision of the proof of liabilities system gets worse as fewer people take part in it. And these are really, big compromises that we need to accept here, and possibly in our hope that we can improve on that. In terms of enforceability, there is not too much on the table. Generally speaking, UTXO sharing schemes that are being discussed these days, just for example, ARC or others, I really like them. I just want to say, but they usually require frequent settlement on-chain somehow. You can do one transaction that represents 1,000 transactions and so on, but there needs to be some kind of activity on-chain. And I think, I don't know if we can achieve a similar level to that. I think there are also alternative proposals, zkcoin, so on, that allows you to unilaterally exit, and you have to accept certain properties with that. What sounds more realistic to me, and I think this may be something that we can achieve with a lot of research, is when we are able to prove that the mint is cheating, also build a system where you can punish the mint that is cheating. This sounds more realistic, that we can achieve this in the future. And I want to refer here to Abdel's talk, one of the talks I'm looking forward to the most today, who's going to be talking about Starks and Cashu. All right, I want to come to the last part of my talk here, and this is going to be more of a zoom out generic view of our way of working on this protocol together. And I want to talk about a couple of principles that I want to suggest to you, the developers here working on these systems, or ideas that I care about. I just want to make clear, this is, I don't mean moral principles with this, like openness, fairness, beauty, and so on. Like I like these too. What I mean here though is technical principles, protocol specific principles. All right. So we are all working on a protocol. That's important to realize. Many people are working on their own projects, but we're all a single community speaking the same language because we want to be compatible with each other. So although everyone is doing their own thing, we're independent people working on independent projects with independent goals, it's still necessary, or at least very helpful, to have a general direction that we want to move on together. So I want to propose a couple of points that I'd like to share, and hopefully also in the next couple of days we will have opportunity to discuss these points. So I summarize these with 4 principles. I call it, first of all, minimize dependencies. Second, isolate responsibilities. The third one I call listen to operators. And the fourth, advanced research. So Let's go through them. Minimize dependencies. What do I mean by that? So with minimized dependencies, I mean that the Cashu protocol specifications should only be weakly coupled to other protocol specifications, as weakly as possible. And this is not because other specs or other protocols are bad. It's just a more stable and better way of building your protocol itself. I want to give an example to make this more concrete. In the very first version of the Cashu protocol, which hopefully most people don't remember anymore, we basically assumed that the entire world is Lightning, Bolt 11, and there is nothing else in the universe. Every payment will be Bolt 11 until the end. This brought so many problems once we started to extend the protocol, because we realized, or we had this idiosyncrasy, and we thought this is going to be the way that we're going to do things. Since then, we've cleaned up the entire protocol. We threw almost everything away and have something we call now the V1 protocol, which is the protocol that everyone uses today. But this protocol essentially treats Lightning as just one method of paying. And this allowed us to just recently, SimpleKit did an implementation just recently of that, to implement Bolt 12, for example. So we were able, through minimizing the dependencies or coupling it way weaker to Lightning, to include a different payment method just like that. And for right now, Bolt 11 and Bolt 12 are just nothing than a simple payment method in the protocol. And this method could be anything. It could be give me physical cash, could be make a credit card payment, or make an on-chain payment. Another example, I think this is a bit nerdy, but I still want to mention it, is the 33-byte versus 32-byte key size discussion. Most people won't know what I'm talking about, but others will do. So the Nostr protocol has done something that I want to, he mentioned as to be avoided. The Nostr protocol took 32-byte keys from Taproot. He said, no one's using 32-byte keys except Taproot, because Peter Wulle had this genius idea of throwing away 1 bit. And this makes Taproot code to always check a couple of cases. It makes it ugly forever. And the Nostr crowd decided to just copy this, which just works. You can reuse libraries that there are. But when we started interacting with Nostr and public keys as well, people argued like, hey, let's also do the same thing. But then we realized, like, no, if we do the same compromise, then we're limiting ourselves again from the beginning. We will have problems in the future, which is definitely the case, because no one should use 32-byte private keys, public keys. So for protocol design, and only for protocol design, don't hit me, is you shouldn't think like a Bitcoiner, you should think like an eCasher. For everything else, you should think like a Bitcoiner. Next point, isolate responsibilities. So this can be summarized with a simple principle that I keep thinking about, which is if an external service can be implemented, if an external service can achieve the same thing as a new feature of the mint, then make it as an external service. Don't make it as a feature of the mint. Examples: atomic swaps, LNURL, we have npub.cash, for example, trading, brokerage, backups. These are all services that a mint could offer. But it doesn't have to be the mint. It could be a third party offering these services as well. Atomic swaps, for example, in the case of Fedimint, we have these gateways. So there's a very good reason to take out features from the mint, because it makes it, first of all, simpler, leaner, more stable. Also, it makes the whole system a lot more cypherpunk, which means you can build a mint that doesn't do much, but it allows the users to do a lot. And if you do that, because of the privacy, the mint doesn't really know what's happening, it can control it. So it becomes a lot more fuck you money, in the sense that you can do whatever you want and no one can stop you. Listen to the operators. Here, one example is blind authentication, one of the projects that I've been working on the most in the last couple of months. I'm very excited about this. Will soon also be a protocol specification, and people will be able to review this. And the idea here starts with a quote I want to give from a person I've known for a couple of years, who's working on a physical Bitcoins community project. They have hundreds of users, dozens of merchants. They do the Bitcoin thing. And this guy takes care of the entire infrastructure. He is the technical Bitcoin of his community. And he told me, I don't want to know what my users are doing, but I also don't want to run a mint for the entire world. Like, they want to use ecash, but this is their problem. This image is from the Mutiny guys as a homage to them, since they sailed into the horizon. They have built something very similar to what I'm going to present in the next slide, which is called blind authentication. This allows you basically to achieve what this guy needs. So blind authentication is essentially a balance between safety and privacy. It allows you to limit the use of your mint to a closed group. So you can say, for example, everyone who's here on the conference gets a login code from me or a one-time password or something like that. You can use this to blindly authenticate with the mint. And then after you've done that, what you can do is you can prove that you are one of the people in the group, but you don't have to say which person you are from the group. So a business or a community could say, I know exactly that I'm only servicing my clients or my people, but I don't know who. And this is what they need. One example of a company that that figured this out, that this was a good idea, is Google One VPN. It's an amazing service that they're shutting down, obviously. And Google One VPN has the same problem. So you pay Google to use a VPN service. They need to know whether you've paid or not. This is like no question. But they don't want to know which user you are who paid for the VPN service. So what Google One VPN does is the same thing as ecash. They just don't call it ecash, they call it RSA blind signatures. But you log onto the Google service, you prove you have paid, they give you a blind signature, you unblind that, and you use that blind signature to use the VPN service. Now I come to the end, and I have to go through this list very quickly, what I call advanced research. I just want to say here that, you know, Cashu as a library and a system has been used and is used as a basis for more things that you can build on top of ecash. As an example, I want to give this the DLC proposal by Conduition. It's a very complicated proposal that allows you to implement DLCs for ecash. And Tom, who's maybe here, has implemented this on Cashu. And this allows you, like, the story makes it very apparent that if you have a great idea on how to improve the cryptography, you don't need to recode the entire thing. You can just use the entire framework. You can rip out the crypto in Cashu and just put your own crypto in there and just use an ecash system without having to do the heavy lifting. And this is very good news, because there is decades worth of ecash research, most of which hasn't been realized. We've heard this from Nifty today, because there was nothing to realize it on. Most of the genius ecash ideas are still buried in research papers that have never been coded up. So examples are federated ecash. Fedimint is pioneering with that. Amount blinded ecash. Wabi Sabi is using that. There are accumulator designs where you can, compress the state of the database to a very short piece of data. Fraud proofs and punishment, I just quickly mentioned that. You can maybe prove in the future if the mint is behaving correctly or not. Zero knowledge proof for programmable ecash. We can make ecash smart contracts that are indistinguishable from each other. Merkle tree-based bookkeeping. We can put the entire database of an ecash mint into a Merkle tree and then do all sorts of inclusion proofs, exclusion proofs, and crazy stuff. So these are the 4 principles I want to suggest. And when you have principles, you can build a house. And when you have a house, you can make nuts. And I like to say this, but this time I really don't have any time. So I just want to mention the internet is completely fucked. The payment systems are completely fucked. The entire ad industry is doing anything they want with your data. We have so much to fix, and Bitcoin is one part of that. And I believe ecash will also be a big part of that. There are so many custodians out there in this world, so many. All of them can upgrade to a better system. So if you're interested, you can become a contributor. We have many different libraries. Whatever language you're speaking or programming, I think we have something for you. Just join us. On this site, you can see all our specifications and docs and more information. If you want to support Cashu in the development of this protocol, you can support it via the Open Cash Association. It's a non-profit for supporting the development of the Cashu protocol. And with that, I'm really looking forward to the next couple of days. I'm so stoked that all of you are here, and thank you for the attention.